Alright, so remember on Friday we looked at our product and quotient rule. The last thing that we looked at was using those from a table. Which, at the end of the day, remember our table one should just be like easy money, okay? Like it's really straightforward as long as you know your formulas. We are just plugging and chugging into our formulas. Like that's it. Like you don't have to do really any math. Because if you just left it here, right, where I plugged in my values, and here where you plugged in your values, that's full credit. So there's really very little math besides just knowing your formulas. So speaking of formulas, when we're dealing with our quotient rule, okay, a really common thing that they tend to ask, and I will ask, is, that should say tangents, okay, is once we find that derivative, remember if I'm using my quotient rule, I end up with a fraction. So we tend to ask, where does the function have horizontal tangents and where is that derivative undefined? So let's first look at just taking the derivative. So what are we going to use? The quotient rule. So what do I start with? The bottom, so low, so x cubed times the derivative of the top. So what's the derivative of the top? 2x. Right, bring down my 2, subtract 1, so we get 1, and then the derivative of -1 is 0.
Could you please send Reagan Blanc to the main office for a moment?
Yes.
Thank you.
Okay, then what? What's the derivative of x cubed? Okay. All over x to the 6, right? Because I'd have x cubed squared. Now remember, if it just asked for our quotient rule, we could just stop there. However, since we're going to be like doing some stuff with it, it is helpful to go ahead and simplify this. So x cubed times 2x gives us
2x.
okay. And then we're going to distribute that. So this would become positive 3x squared. Yes? No, maybe? So then 2x to the 4th minus 3x to the 4th gives us
Negative x to the 4th.
okay. Is there anything else that I might want to do?
Did you factor out an x squared?
I can reduce everything by an x squared. So if I factor out an x squared and then reduce, I'll be left with negative x squared plus 3 all over x to the 4th. Now you would be fine if you left it like the second to last step, okay? It just takes a little bit more simplifying once we start doing stuff with it. However, you will see on a lot of times on multiple choice questions, they will factor out a common factor and reduce. So just like if you get to this step, just be able to see, I have an x squared, that's my answer. Does that make sense? Okay, so that's my derivative. That's that answer. So where does the function have horizontal tangents? What does it mean to have a horizontal tangent?
The slope equals 0.
Okay, and what is the slope of the tangent line?
The derivative.
The derivative. Are we okay with that?
Mm-hmm.
So that means that our derivative must equal
0.
0. If I have a fraction as my answer, what does that mean I really care about?
The top.
So remember, the only place I can actually equal 0 is the numerator, right? Because 0 divided by anything, as long as the bottom is not 0, will give me 0. Yes? So but ask us, where it is horizontal tangent, right, I am setting my numerator. equal to 0. Yes? Okay, so what's my numerator?
X squared.
Negative x squared plus 3.
Plus 3.
So what would we do to solve that?
Minus 3.
Okay, and then?
Square root.
Not yet.
You make everything positive.
Yeah, well, you gotta divide by a negative first, right?
Or what?
So we would get a positive 3. So subtract 3 divided by 9. Then I can take the square root, and what do we get?
X equals square root 3.
Almost.
Plus or minus square root 3.
There you go. Now this question can be asked kind of 2 different ways. The first way is just where does the function have a horizontal tangent, which means that they're just looking for an x value. So that would be my answer. Okay. The other place is like it could say like state the points where there are horizontal tangents. So then what would I need to do with this value? Plug it back into the original equation. Yeah. Now, when I end up with a number with like square roots of 3, that's probably where they're just going to be like state the x value or where does it happen. If we got like a nice pretty answer like 0 or 1, something like that, that's usually where they would ask for the whole point. Does that make sense?
Yeah.
Okay. Now, second question, where is the derivative undefined? So again, I have a fraction again. So where are we going to be undefined for that fraction?
Here.
Why?
Because it's the denominator.
Yes, so we're going to be undefined when our denominator equals 0, which, yes, in this case is x equals 0. And what does that mean for the original function? If our derivative is undefined. What is our derivative?
The slope of the tangent.
Okay, and if a slope is undefined, what does that mean? Vertical. That means that our original function has a
Vertical asymptote.
vertical. It could be a vertical asymptote, which in this case it is, but it could also be a vertical tangent. Because where we looked at one, well, it looked kind of funky, where it like just went straight up and then curved back out, so that would still be considered a vertical tangent. But for the most part, ours are going to be vertical asymptotes. Now, the last part is asking to find the second derivative. How do I find a second derivative? Take the derivative of the derivative. Are we all okay with that?
Yes.
I'm gonna give myself another page because I'm running out of room. So, what are we gonna have to use again?
The quotient rule.
Ooh. Alright, so I want you to find the second derivative on your own.
Okay. Huh?
Go, find the second derivative. Now remember, we are going to have to apply our quotient rule again, so I can't just take the derivative of the top and the derivative of the bottom. We have to apply our formula. The reason why we got a quotient formula is because when I have quotients, we have to use it. hopefully most of us are able to at least get here, right? Because this is just the rule, right? Everything after this is just algebra stuff, which is usually where y'all tend to make the mistakes. But remember, if I just asked you for the second derivative free response question, that's my answer. I'm not simplifying anything. You are stopping while you're ahead, banking all of your points, because if you start simplifying and you mess up, now you don't get that anymore. So, however, the way that I would simplify it might be a little bit different than the way that you would simplify it. So most of y'all would probably like distribute the 4x cubed and then simplify. I noticed that I have an x cubed in common with everything, so I'm probably going to go ahead and reduce by an x cubed to start with. So this would just become x times negative 2x minus 4 times negative x squared plus 3 all over x to the 5th. And again, if you did it slightly different than me, that's fine. As long as you ended up with the same thing, then that means that you did it correctly. So, we get 2x squared minus 12 all divided by x to the 5th. Yeah.
So we don't have to write, like when you pull out factors, you don't have to write down the size.
You don't have to write down the what?
Like, you know how you pull the x cubed out of there?
Uh-huh.
You don't have to write it beside it.
So like, oh, you're saying like, technically my next step, yes, would have been to factor out an x cubed. I would have written the x cubed in the front, and then I would have reduced it with my denominator. I just did that all in one step.
Right.
Because I already have it, like,
So
question?
No, you can just leave that as is. Like, you don't have to write an x cubed beside it because you took out an x cubed out of it.
But I took an x cubed out of the top, and I divided it with an x cubed in the bottom. So like, x cubed divided by x cubed is 1. Like, if I left this as x to the 8th, then yes, I would have had to leave my x cubed up top. But because I reduced it, they went away, because those reduced to 1. So that's why I said, like, yes, I did that, and then I reduced all in one step. Because that's already long enough, and I didn't want to write that out again. Which is fine. Like, it's like, this is enough. There, okay, let's clarify. You have to show some work, right? Like, there's no way that you went from step 1 to last step all in your head. Okay? If I can't do it in my head, there's a pretty good chance that you can't do it in your head. Right? However, do you have to show every single step? No. Okay? So, if you want to skip a step or two, that's fine. That also is going to help you go faster, which is important because remember your tests in here and the AP test are timed, so you really don't want to write out every single step. What other questions do we have? You all okay with that?